Good morning. This is Miss Pollock, and I'm going to talk to you about Newton's third law today. So, this is a practice problem from your packet. It's number 5. So, first it says to draw and label an interaction diagram. So, I have block A interacting with block B with a normal interaction, an applied interaction from the hand to block A. Both blocks are interacting with the floor with both a friction and a normal interaction, and both blocks are interacting with the earth. All right, so then it says to draw free body diagrams. Since block B only has 4 interactions and 4 forces, I'm going to start there. So block B, I know I have a gravitational force of the earth on B. I also have a normal force of the floor on B. Since there is no change of velocity, my vertical forces have to be balanced. Horizontally, since A is to the right of block B, I know block A is pushing to the left. So I'm going to call this my normal force of A on B. And it's moving at a constant velocity. So I know my friction force has to be the same size. So I have my 4 forces on block B, and they're balanced because it's moving at a constant velocity. So now I'm going to move on to block A. Block A has half the mass, so therefore its gravitational force is going to be half as big. And that is going to be balanced with my normal force. So now let's see. We've learned when we watched the videos of the carts smushing together, we learned about Newton's third law, that anytime 2 objects interact, the forces between them are equal in magnitude and opposite in direction. So the force from A to B has to be equal in magnitude and opposite in direction from the force from B to A. So that way I will draw my force. Since B is to the left of A, it's pushing A to the right. So my force, my normal force of B to A has to be to the right. But I also have a friction force. My friction force is going to be the same size, right? So I also have my friction force of the floor on A. And since it's moving at a constant velocity and my forces are balanced, the force, my applied force of the hand on A has to be twice as big in order for it to be balanced. So there's my applied force of my hand on A. So if I want to highlight my force pair, my force of B on A and my force of A on B, you see they're equal in magnitude and opposite in direction. So when we have a force pair, when 2 objects interact, how about if I spell objects right? When 2 objects interact, the forces between them are always equal in magnitude and opposite in direction. These are called force pairs. And it's because of Newton's third law. The cool thing is we can also see this force pair on your interaction diagram. See this right here, this interaction between A and B? That's the normal force of A on B and the normal force of B on A, which are equal in magnitude and opposite in direction. All right then, Newton's third law. Let's rock and roll. Have a great day.